continue the question and answer session now. I'll invite all of our speakers to join Julie and the boys up here. And while they're coming up, I might take the opportunity to ask a question of Tom, if he's still on the line with us. Are you with us, Tom? Oh, hi. Tom, you talked about accelerating and democratising the use of Illumina's technology and exploring data sharing models to achieve that. I wondered though, it's big business and no doubt there's a lot of money to be made. What competitive conditions are there on Illumina's desire to share data, and how much of a barrier do you think competitive strategy will be to creating the kind of social value that could be possible through the collaborative development and application of genetic sequencing?
It's a great question, and I don't know that there's a short answer. I mean, to begin with, we see ourselves as a technology provider. So we just recently released, I think, 91,000 SNPs into ClinVar, which is the clinical variant database, and we believe philosophically that data and information, especially clinically relevant data and information, needs to be shared and needs to be in the public domain. So our business model has very little to do with proprietary information around SNPs or around genes and their cause. But that is a challenge because there are many companies that are out there that have based themselves on this. There are new companies that have been set up around genetics and databases and linking into social behaviour and all sorts of other things. So, you know, I think, and I can't speak for the company as a whole, but our belief is we would like to have as much data in the public domain as possible. The more that's in the public domain, the easier it is going to be for diagnosis and for access to information. But that information sharing does come with its own set of challenges.
Thank you, Tom. Oh, we've got a follow-on comment from Matt.
I just wanted to comment that the genetics community has been incredibly good at sharing data, and that there are massive public international databases now of genetic variation in healthy individuals and people with all different forms of diseases and cancers. And so I don't see that there's intellectual property in the databases. It's going to be in the application of those databases and how you analyse those databases, and in the technology of actually doing sequencing.
Thanks, Matt. That's a very interesting distinction. Now I'd like to open up the questions to the floor. We have some roving microphones going around, so if you have a question, please raise your hand, state where you're from, and if it's for a specific speaker, please direct it to them. If not, open it up to the panel.
Hi, this is mostly directed to Tom, but of course I welcome other people. How do you see the role of machine learning in the future growth of diagnostics? So in terms of the diagnostics growth that you're hoping will happen in the future, like how are we going to achieve that? Is it through stuff like machine learning strategies, or do you think there are other low-hanging fruit to be had?
Daniel, can I ask you to repeat the question, because it's quite difficult to hear off the mic?
Yes, certainly, Tom. Our guest has asked, how are you going to achieve those acceleration goals that you've set? And will machine learning play a role in that, or do you have some other secret weapons up your sleeve?
No, look, the machine learning and artificial intelligence is going to be a key element of that. And we're already speaking to a number of different companies who are in that space. So it's not, you know, a specific strength of ours. There are other companies out there, and we're partnering with a variety of different companies. But machine learning and artificial intelligence they're going to have to play a very significant role in being able to distill the information down to an actionable set of genes, variants, whatever that people can then hopefully take forward and treat or use to help with patient management.
Thank you for the question. Got one up the front here, please.
Hi guys, my name's Malcolm Thatcher. I was the previous CIO for Queensland Health, and now much happier and saner unemployed writer. So very happy to be here. A question for the panel. I had the great fortune in 2014 of visiting, I won't say which facility, but one of the top 5 epilepsy clinics in the US. And they welcomed me and embraced me and allowed me to follow them on rounds and do their debriefs, actually observe surgeries, etc. So it was a great experience. But I have to say that when I think back to that centre, the predominant, way in which they dealt with epilepsy was to do brain resections. So, we're talking about cutting someone's part of their brain out, and we look fast forward 3 years, and I just wonder, the question is, at what point, or where will be the tipping point where clinical practice actually embraces genetic research, because in the ground rounds and the other sessions I sat in on, no one was talking about genetics. So they were talking about electrical therapies, the brain resection interventions, but what point do you see there will be a tipping point where genetics will actually be mainstream within in this case neurosciences, but in other areas of medicine?
Okay, I'll answer that one because you put a focus on epilepsy there. And you're absolutely right. It's not mainstream at the moment. So just as an example with the epilepsy work that we've done, it's taken us several years to actually set up a panel that encompasses all of the 395 genes and to get that accredited and go through the system. It's kind of investing in time and expense to do that, and setting up our bioinformatics pipelines so that we can use that whole exome information to funnel on those 395 genes and call results. So that's taken time. But the biggest problem is the take-up. We're accredited, we're ready to roll, and there's no take-up. I find it astonishing. I recently spoke at the Australian Neurology Association, and there are quite a number that understand we do the familial hemiplegic migraine and the ataxias, and we've been doing that for a long time. So I think there are people who know out there, and it's starting to make it, we should test that one. But the epilepsy stuff, we've been ready for about 1.5 years now, but the take-up is very low. We've just started, I think we've got 3 samples outside of the Dravet ones, which we do. So that's the biggest thing. How do you actually get people to change their mindset? And I think Matt alluded to David Bunker and the Queensland Genomics Health Alliance. That's part of their role, is to start getting this information out there and to get it mainstream so it happens. At the moment, they can't do that for all disorders, so they've picked some specific demonstration projects that will be coming out of Queensland, and there are some that are coming out of other parts around Australia. It will take a while before we start to get genomics right across everything. Personally, I'm hoping that epilepsy starts to make a difference, because I think, as I was trying to get across in my talk, you don't want everybody to be having brain resections. There are some good treatments for epilepsy, just like with cancers, but it's better to go hand in hand with the genetic driver behind it so that you give the right treatment. But somehow we've got to change that clinician outlook a little bit and get it involved, and give us a few years, and hopefully a few dedicated people like David and Annie Chen down there who are trying to get this out through Queensland and Australia.
Thank you. We've got a question in the centre.
I have a question. Bram Koppel on QET, for Matt in particular. So most of your work is based on personalised medicine and treating people. How can you use your work for actually preventing diseases happening in the first place, particularly non-heritable ones?
So preventative medicine really has to be targeted before you can actually be successful. If you just try and apply preventative medicine in most circumstances across the whole population, it's not really possible. So genetics offers you an opportunity to help predict who's actually going to get disease. And most common diseases are actually significantly heritable, and it's likely in time that we will be able to use the person's genetic makeup to contribute to predicting whether or not somebody's going to get disease, or to pick up people with really early disease, and that will enable people to change the practice of medicine from treating established disease to either treating very early disease or preventing disease. So just to come back again about this issue about genetics translation into clinical practice, a common misconception people have is that that treatments based on genetics are going to be genetic treatments, that we actually need to actually treat the genes. In fact, that's going to be a small minority of treatments based on genetics, and the vast majority of the application of genetics information will be about changing treatments that we already have, or conventional treatments based on genetic information.
Thank you.
Could I have one extra? If I'd had a bit longer, I was going to actually give an example of that. So as an example, there's one known susceptibility gene for migraine, so it makes people susceptible. It's got a mutation in it. It occurs about 20%, common disease of migraine with aura. And for that one, it's an enzyme that's produced at about half the normal level if you actually have this mutation. The cofactors for the enzyme have been known since the 1980s. They actually are a series of B group vitamins. And we've now done 3 trials, so phase 1, 2 and 3, involved almost 1,000 people, placebo-controlled, and shown that by adding those particular cofactors, you can make the enzyme work faster, even if you have the mutation. More importantly, it had a really good preventative effect on migraine. It dropped their frequency, severity, and the pain and disability associated in only those who had that mutation. So that's actually a preventive.
That's a great example, Lynn. Thank you. We've got a question at the rear of the room.
Oh, hi. I'm Josie DiDonato and I work for the Health Informatics Society of Australia. And my question may be similar to the one previously, but I just wanted to say currently chronic disease and the management of chronic disease is a pressure point for the health system. Just wondering what application of genomics we would see assisting that in terms of, susceptibility to those diseases. Anything to add?
Well, I guess that's sort of like the question about preventative medicine that we were talking about before. So genetics will actually lead to a lot more understanding of the causation of chronic diseases, and has resulted in really big advances in some areas in treatment of chronic diseases. And I'm particularly thinking here immunological diseases, where over the last decade genetic discoveries have led to treatments which have actually totally revolutionised management of common rheumatic diseases like rheumatoid arthritis, psoriasis, ankylosing spondylitis, that affect 2 or 3% of the population. So that now there are highly effective treatments available for those. So that's one way. And another way, hopefully, will be to pick people up whilst they're in the early stages of these diseases, so that we can actually introduce appropriate targeted preventive approaches in people who are at high risk of getting long-term disorders like psychiatric disorders and so on, which cause a huge public health cost to the community.
Thank you. Do we have any further questions? Yeah, one down the front.
I had one for the boys, actually. You guys have obviously had some big challenges, but you're also making the most of your opportunities. You've got a room full of really clever people there. I don't know about you, but I sort of understood probably less than half. But if there's one thing that all these clever people could do to make life better for you, what would it be?
Well, I haven't thought of this question much, but as much as they've done, I'm not sure how much more they can do, because I have had all the operations at the moment that are possible, but if it was to do one thing, it would be I would want to walk properly, but I'm not sure. That's more on me with my exercises and that than all them doing other things to my legs. So yeah.
I don't know. I think that's a challenge for all of us here to help you do that. So good on
Thank you, Harrison. Max, did you want to add to that? No. You don't want anything?
Max made it clear he's here for the breakfast. Yeah.
Isn't that lovely, the way Harrison is so grateful and taking responsibility? You're an inspiration. Do we have any further questions before we wrap up this morning? Yep, one here.
Yeah, hi, just a question for all the speakers. Have you tested yourselves?
Good question.
Go on, Matt. He's got the perfect genome. It's nauseating.
Yeah, sorry. I've had my whole genome sequenced, and it was extremely boring, and they didn't find anything that was particularly fascinating. I suspect that means they kind of look too hard.
I personally haven't tested my own, but my husband's family, his last name is Smith. I refuse to be Mrs. Smith. He's got a family of 8,000 people, so I couldn't help myself there. I've been going to those family reunions and getting DNA samples. So they've been helping with our studies. It's one of our pedigrees.
Let's go back to that consent issue, Liz. I'm joking.
What about you,
Actually,
AD?
there's a
But
serious
you're
point behind
coercion,
all of this, which is that in deciding whether or not to get sequenced, there are all of the issues that Aideen raised about what you might find that you weren't expecting. And I have to say, even though it was boring in the end, it was actually a very nerve-wracking thing that I didn't know whether they were going to find that I was at high risk of, for example, Friedreich's ataxia or Huntington's chorea or motor neurone disease or some condition that I really didn't want to have. And it was also something that we had to discuss in the family too, because as Aideen pointed out, half of my kids' genome comes from me, and it had implications for them. So it was a discussion we had to have with them as well. So it's actually it's a quite a complex decision to do about what to do, and it's not something which you should do just by posting away a spit sample off to the United States or anything like that. It's something you had to go through a proper process and discuss with people beforehand what you want tested and how you actually want, what you want to be told at the end of it.
Okay, we've got one final question at the rear of the room.
Hi panel, thanks for today. I'm a student from QT, my name's McCabe. I just have one question for each of you really. It's just, if you could change one thing in your industry at the moment, what would it be?
Actually, I think it'll go back to the question over here. I would like some clinical uptake of diagnostics. I think we need to be working hand in hand with clinicians to ensure that all of this technology and all of the benefits from a personalised approach to treatment are actually realised.
Pretty much the same thing. We have the capability of doing a phenomenal amount across common and rare heritable diseases and cancers, and it's uptake and application of it which is really needed.
Yeah, I've got one. Go on, yes. Yeah, so it's a great question, and I think that's it. I mean, idealistically, in a Pollyanna kind of a way, I would like to think that everybody who would benefit from this has the opportunity to get sequenced and have the sequencing done, and that it is offered to them in a way that they have the chance to make a decision about it, i.e. somebody who's giving them that information is well qualified and understands what all the ramifications of it are. I would also like to see genetic non-discrimination legislation in Queensland to start with, and then on a federal level as well. I think that would free people up hugely to seek genetic services as well.
There's some fabulous aspirational action steps. Any further comments from you, Julie?
As a parent, I would just say that so our gene is called Ripley2. And I think from a parent's point of view, if we could then have maybe introduced to people who then can help us to see if there is a way that we can get Harrison up walking, because I don't know doctors, I don't know specialists, I don't know the avenues. So if we could somehow have that, I think that would benefit families.
A way of connecting the people that need the services
Correct.
with the expertise.
Definitely.
Gentlemen, do you have anything further to add? Harrison or Max? Well, everyone, please join me in thanking all of our speakers this morning.